Okay, part 2. So we got to here, and remember, we got to remember to change that because we reverse things. So negative 1/3 x plus 4/3. And what they're saying now is we're going to put x as negative 9 in here. So this is literally telling us if we go like this and we plug it in here, we get negative 1/3 times negative 9 plus 4/3. This would be 3 plus 4/3. If we wanted to find common denominators, it'd be 9/3 plus 4/3. 13/3 would be our answer for that problem. Okay, so number 7a says show and sketch and explain why tangent of 270 degrees is error when you type it in your calculator. You can go ahead and type it in your calculator, but what it's saying is you take your spinner, you spin it 270 degrees, but remember this is a quadrantal, so we don't want to literally get to 270. Don't ever go back to your y, always go back to your x, and we look at that. That's our adjacent side, which is 0. Here's our opposite side, which is considered negative because it's down, and our hypotenuse is always positive. These two things are equal, but this is the main thing here. Tangent is defined by opposite over adjacent, and when you get a 0 in the denominator, that will be error or undefined. Now it says show and graph and explain why cosine of pi, so we'd flip our spinner to pi. I'm going to stop just shy of it, come back to the x. Now if you take a look, this is my hypotenuse, which we'd consider 1. This is my adjacent side, which is negative 1 because it's left, and my opposite side disappears. Now cosine, remember, is adjacent over hypotenuse. We'll notice adjacent's negative 1, hypotenuse is 1, so it'd be negative 1 over 1, which gives us our negative 1. So we showed it and we explained it. Okay, number 8. A lot of questions about this graph. This is your y equals sign, and it's asking us where is it increasing. Now my drawing is going to be pretty messy by the time I'm done, but remember we got to think left to right when we're thinking increasing and decreasing. So where's it increasing? Well, if you're on a roller coaster and it's starting here, you're definitely increasing from there to there, and you'd also be increasing from there to there. So that's when your roller coaster would be going up. Now this is kind of blurry, but from 0 all the way to 90 is where you'd be going up. So we'd say x, our x-axis, or our theta, if we want to talk about degrees. In this case, theta greater than or equal to 0, less than or equal to 90, and from 270 to, I think that's 360. So 270 and 360. Didn't leave you guys much room there. Decreasing. Well, let's get out a different color marker here. Decreasing. Where would your joyride be going down? Well, that'd be going down from only there to there. There's one place where it's decreasing. So that's from 90 all the way, I think that's 270. So decreasing from 90 all the way to 270. Now concave up means if you go both directions, you're going to go up. Now there's multiple answers for this, but I'm going to go with orange. Someone could pick from here to here, and they're not wrong, but you could also pick from here all the way to here. And that's what I'm going to do. I'm going to pick this right here, because if I go both directions, left and right, I'm going up. So that's from 90 all the way to 360. Now concave down, we're going to make blue, and that is both directions down. You could pick from here to here, or you could pick from here all the way to here. I'm going to take the longer of the two, Again, there's multiple answers for this, but I'm going to pick that. So from 0 all the way to 270, it's considered concave down. Someone else could have said from 0 to whatever that is, 130, I think? No, 150. Local maximum. Well, that would be right here. So that would be 91, or pi over 2 comma 1. A lot of times you would just talk about the maximum value being 1. So I'd be looking for the y value in your answer. Local minimum is right here. So that goes down to -1. If you were talking about a coordinate point, you'd say 270 and then -1. But technically it's a -1 minimum value. Okay, number 9. Solve the following. Well, we're going to add 3 to both sides just to get going. So we get 4 sine squared x equals 3. Divide by 4, divide by 4. So I get sine squared x equals 3/4. Now don't forget this. Bada boom, bada bing, do the right thing. We've got a lot of possible answers here. So that's plus or minus the square root of 3 over 2. Remember, that's equal to sine of x. So this is my opposite, this is my hypotenuse. We got to figure out a drawing. I'm going to come over here. We're going to run out of space for this one. And try to draw everywhere where the opposite side is the square root of 3. So I got the square root of 3, my hypotenuse is 2. This is looking like a good old-fashioned 30, 60, 90, and it is. So that means it would happen over here also. And it would happen, and notice it's plus or minus, so we can go all the way around this negative square root of 3, 2, and then we can go here as well. 60, this is negative square root of 3 over 2. So you can see all of our answers would be 60 from here. So that's pi over 3. And then we get 120, which is 2 pi over 3. And then we get 240, which is, oh, come on, 4 pi over 3. And then we get 300, which is 5 pi over 3. Okay, now they might also, let me pause this a second. And what makes this problem tricky is they don't give us domain, they don't give us limitations on x. So to technically solve this, we'd have to continue our thought process and say, as the spinner just keeps going around and around and around and around for infinity, we would take all of these answers, and if we added, that's a whole number times pi. In other words, let's look at this pi over 3. It's right here. If we went another pi, it would also give us the correct answer. And if we just kept going, it would just keep spitting out the same answer. And that's true for any of these answers right here. So that's a fancy way to say, you know, if there's no limitations, there's an infinite number of possibilities. So that's a little twist on this because there's no limitation given. Now let's look at this one. We got something times something equals 0. Our thought process is one of them or both of them needs to be 0. So tangent of some angle is 0, but also 2 cosine of some angle plus 1 is 0. Now this takes us to our quadrantals because our opposite, tangent is opposite over adjacent. So this is really asking you, where does the opposite side disappear? Because that's the only way you can get 0. And if we take a look at our quadrantals, it only happens at 0 degrees and 180 or pi. So there's 2 of our answers for this. But if we still got to answer this, so subtract 1, subtract 1. So we get 2 cosine of x equals -1. Divide by 2, divide by 2. Where does cosine equal -1/2? Well, if we take a look at it, knowing that adjacent over hypotenuse is the definition of cosine, my adjacent side would have to be a -1. Now, we already have that drawing up here, so I might not repeat it. All right, just needed that space here. So we already have the drawing where cosine equals -1/2. It would work here, where we spin our spinner 120 degrees. So x here could equal 120 degrees, because that would give us this triangle here where adjacent over the hypotenuse gives us -1/2, but also this spin all the way to here, so that'd be 240. Now, for this problem, you can see we've already got 4 answers. 1, 2, 3, 4. Well, once again, the tricky part of this is there's no limitation on x. They don't give us the domain, what window to give our answers. So we got to think of it as, hey, there's an infinite number of answers. So 180 gives us the same thing as 0. So we could do one of two things. We could say 180 plus n pi, or we could say plus, and that's a whole number. And we could also say and 2 pi, because that would take us back to itself. So there's a number of ways we could do this, but 180 in this situation is the same thing as 0. So I'm going to stick with this, and I could also go n pi here, because 0 is the same thing as 180. Now here comes some a little trickiness here. Because of the negative, I don't want positive, so I don't want to end up here, and I don't want to end up here. So in this drawing, 120, I would have to say, okay, plus n times 2 pi, because that means it would give 360 as many times. Just get back there, you're going to get the same answer. And that's the same thing for 240, n times 2 pi. All right, so that's kind of tricky. This little piece is a little tricky. It's a lot easier when they give us a domain. Okay, number 10, sketch the graph of x squared plus y squared equals 25. At this time, you're supposed to know that that comes from our generic equation of a circle, where this is r squared. Because there's no x plus 2 or x minus 2 or y plus 2 minus 2, we know that our center is 0, 0. And our radius is going to be 5, because we take the square root of that. And that's why I have this drawing over here all the way, all the 5s. Not going to be a pretty circle, but we're going to get her done here. There it is. Okay. Is it a function? Why or why not? Well, vertical line test, you can see, hits in 2 places, so it's no. Why? Because it hits in 2 places. All right. In order to make it a function, would you restrict the domain or the range? Well, if I took off half of this drawing, it would now only hit in 1 place. So that means I would restrict the range here, and I'm going to say the range could either be restricted from 0. In other words, if we literally took the bottom half of this circle off, then we would only be, that vertical line test would be hitting it once. So I could restrict the range. I could say y is greater than or equal to 0, less than or equal to 5. But I could have also said y is greater than or equal to -5, greater than or equal to 0, and that would be cutting the top half off. And then it would pass the test, the vertical line test. Okay. Now a doozy. Okay, so I worked ahead a little bit just to make sure we understand this. Sketch the graph of y equals tangent without graphing calculator or Desmos. Show and label 6 asymptotes. Okay, well, first of all, definition of tangent is opposite over adjacent. So the first thing we're going to do is wonder, where are our asymptotes? Well, this is where my adjacent side turns into 0. We look up here at 90 degrees and at 270, the adjacent sides disappear. So I know at 90 there's going to be an asymptote, and I know at 270. And that kind of kick starts me, because there's 3 asymptotes, 4, 5, 6, just following those instructions. Now we're going to figure out, where does tangent equal 0? Well, that's where the opposite side is 0, because 0 over any number is 0. And I got this drawing over here. Opposite side is 0 at 0 degrees. It's also 0 at 180. So at 180, I know it's going to go right through here, 0, and at 0, it's going to go through here. And we're going to use a little bit of our memory from just learning that tangent looks like this. So we're not going to graph every point by hand. We're just going to get it started and then go right like this and just fill in every window right there.